So welcome to today's Interspecies Conversations talk. This is a regular series of online talks that gives the opportunity to invite leading professors, scientists, researchers, and artists to share and present work that contributes to advancing the acceleration and understanding of the diversity, forms, and functions of communication in other species. The series showcases emerging ideas and discoveries and hosts open discussions where the community can join the conversation with ideas and feedback. Today, we will hear a 30-minute talk with a Q&A. So this talk today is called Bowerbirds, Optimization, the Evolution of Aesthetics and Art. So our speaker, Sophia Brueckner, has a special guest with her today, which is Professor Gail Patricelli from the Department of Evolutionary Biology Ecology from the University of California. So today's talk will look at male bowerbirds and how they attract female mates by constructing an elaborate bower and arranging colored objects around it. Though there are similarities in their process, different birds choose and arrange objects in a surprisingly different way. Their creations transcend easily measurable metrics like efficiency, quantity, and strength. Their curation and composition process cannot be easily translated into an algorithm. So Sophia is an artist and engineer who researches how technology shapes us. As a Google software engineer, she designed products for millions. At the Rhode Island School of Design and the MIT Media Lab, she researched the empowering and controlling aspects of technology. Her studio, Tomorrownaut, prototypes and encourages alternative futures by challenging limited visions of technology and embodying an attitude of critical optimism. She is an associate professor at the Stamp School of Art and Design and directs the Center for Ethics, Society, and Computing at the University of Michigan. Her colleague Gail is Professor of Evolution and Ecology at the University of California, Davis. She received her bachelor's degree in biology and art from Whitman College and PhD from the University of Maryland. She was a postdoctoral fellow at the Cornell University Lab of Ornithology. Professor Patricelli and members of her lab study the conservation of birds and the evolution of breeding behaviors. So on behalf of the Interspecies Internet trustees, please welcome Sophia and Gail for this special talk today.
Thank you so much, Kate. This is going to be so much fun. I'm so delighted to be having this talk. Let's see if me sharing my screen is going to work. Zoom has just changed their UI since yesterday. You should be seeing my screen now, I hope. Nodding? Okay. All right. So Kate might be one of the exceptions, but I'm really surprised by how many people are unfamiliar with bowerbirds. They are just incredible creatures, but I constantly meet people who have never heard of them before. So before I get into what bowerbirds have to do with the ideas of optimization in art, I just want to tell you a little bit about the birds themselves. Bowerbirds live in Australia and Papua New Guinea. There are 20 species of them. Some places say maybe even as many as 28. It depends on how you classify species of birds. Most, but not all bowerbirds build a structure called a bower. I want to emphasize that these structures that they build are not nests. These structures are not used for raising their young. Nests are separate. These are structures that are built by male bowerbirds to attract a female mate. There are two main kinds of bowers that you will see today. They're called avenue bowers and maypole bowers. On the bottom of this image here, you see something called an avenue bower. It's what it sounds like. There's kind of like an avenue, and then there's a wall on either side of sticks and grass. Maypole bowers, which you can kind of see in the middle, are more hut-like, and the bowerbirds are building these around a small tree or sapling. These structures, I want to emphasize, are used just for mating. I'm going to get into a lot more detail about bowerbirds and their bowerbirds later on in this talk, but here's just a couple examples of their creations. So this is an avenue bower that was created by a satin bowerbird. what happens in these bowers is the female bird will fly into the bower and she will view this arrangement of colorful objects that's arranged around it. And the male bowerbird will do a sultry dance and sing and show off his objects. It's a multi-sensory experience, a lot like going to an opera. This is a maypole bower created by a Vogelkopf bowerbird. The area, oops, here we go. The area around the bower structure is called a court, and most bowerbirds will fill this area with surprisingly complex compositions of colorful objects. And this is why bowerbirds are sometimes described as the most artistic of all animals. And the differences in their aesthetic choices across bird populations are why some people say that bowerbirds actually exhibit culture. What interests me the most about what they do is there's no simple explanation for these artistic creations. So before we get into more details about bowerbirds, we should just watch David Attenborough talk about bowerbirds because he's the best. And hopefully you're all hearing audio.
So that is how it should be done.
These are satin bowerbirds. The dark black one is an older male bird. The younger green one is also male, and it resembles a female bird, which is also green.
Junior returns to his own bower and tries to improve things. That should probably go just here. Or maybe here.
What they do is so much
Perhaps
like the
he was
artistic
right
process
in
of
the first
humans.
place.
They place something, then they look at it, and they consider whether it's working or not.
He just can't make up his mind.
And the crazy thing is it takes bowerbirds several years to learn how to do
This
this.
could take some time.
The bowers of older bowerbirds are neater and more sophisticated, and they're more successful to attract female mates.
And it's not just about building. The master's bower has something that Junior's lacks completely. Blue decorations really please a female. And the master has gone to town. Junior takes a closer look. What will the master make of his visitor? Rather than drive him away, the master has other intentions. Seduction.
Here we're going to hear some singing, and we're going to see some sultry dancing where the bowerbird shows off his collection of objects.
Juvenile males are almost identical to females. So the master grabs the opportunity to practice his courtship display on him. Junior doesn't know what to do next. So he exits mid-performance.
So sad. Okay, so anyway, today I'm Sophia Brueckner. I'm a professor at the University of Michigan, and I'm a computer scientist and an artist. And so I want to tell you that this talk is going to be through the lens of being an artist and a computer scientist. And we're really lucky here today to have Gail Patricelli. She's a professor of evolution and ecology at UC Davis. And she is studies birds, and she is a bowerbird enthusiast. Between the two of us, I think we have a lot to say about bowerbirds. So now, before I became an art professor, I was a software engineer at Google. So I guess this is like kind of a vent story. This legend of the 41 shades of blue emerged around the time I worked there. Around 2004 and 2005, Google had the problem that they launched a bunch of new products and that they looked inconsistent with each other. In particular, each product was using its own shade of blue. There was an effort to create consistency across all these products, but it was contentious. Each one of these product teams thought that their shade of blue is the best. So it might not surprise you to know that Google didn't approach this problem the way a designer might approach this problem. They attempted to tackle this problem like a computer scientist. So Marissa Mayer, who was in charge at the time, decided, why not just take 1% of our users, test out the different shades of blue on them, and we'll see which one results in the most people to get it to click on links. So Google tested 41 shades of blue to find the optimal blue. And the legend goes that this made Google an extra $200 million. This story is still mentioned by news articles and user experience researchers today. Now, I've never been your typical kind of computer scientist because I have this artistic side. And even though all my studies were focused on algorithms and optimization, the idea of designing something by optimizing simplistic metrics like this made me just feel sick. I just recoiled at the idea of this. I know that colors interact with colors. What you're seeing on the screen here is Josef Albers' The Interaction of Color from 1963. This is something that art and design students still study today. He looked at the way colors interact with each other and change our perceptions of them. I knew that our perception of color changed based on what else is on the screen, the content, and even the user's surroundings. I do think that the kind of experiment that Google did can be useful, but I don't think that you can optimize your way to great design. And in order to convince my colleagues this was the wrong approach, I tried to use my math background to discourage this mindset by asking my colleagues, but how do you know that you haven't just gotten stuck at a local maxima? And the way this made me cringe made my optimization-focused colleagues cringe because local maxima are very scary. Anyway, great art and design isn't this simple. It is not a simple optimization problem. I don't think great art and design can come from optimizing a single or even multiple simplistic metrics. So applying ideas of optimization, running experiments, and surveys to art and design, this was not invented by Marissa Mayer or other computer scientists in the Bay Area. Artists have been exploring these ideas for a really long time, but I'm just going to mention a couple of them. In the early 90s, artist Carl Sims explored the idea of genetic algorithms to evolve beauty. You could see here that he created a row of screens that had different images on them. And then there were sensors on the floor, which would detect which screen people would stand in front of the longest. And that was assumed to be the most beautiful of the images. That image where people stood the longest was used to seed the next generation of images. And those images would then populate the screens. The idea was that over time, the images would evolve to be ever more beautiful. This project is very relevant to think about when we're considering bowerbirds and how their sense of aesthetics may have evolved. Komar and Melamed are an artist team who set out to understand what beauty is to different cultures. They surveyed people in multiple countries to understand what is beautiful and desirable in each country. This project was done in 1994. It's called The People's Choice. So what they did is they surveyed people in different countries with this very intricate survey. This is just a small part of it. They asked people what's their favorite color, what's their second favorite color? Do they like modern art? Do they like traditional art? Do they like indoor scenes? Do they like outdoor scenes? Do they like wild animals? Do they like domestic animals? And then based on the results of all this survey data, they created the most wanted and the least wanted painting in each country. So what you can see here is the most wanted and least wanted painting for the United States. The most wanted painting in the United States was a dishwasher-sized painting that's a landscape with a body of water, a historical figure, and some animals in it. The United States' least wanted painting was a small abstract painting. And what they found is that in most countries, the most desirable painting was a medium-sized painting, probably because you could hang it over your couch, of a landscape with a body of water, a historical figure, and some animals in it. And the least desirable painting was either small or very large abstract works. Unsurprisingly to me, the Netherlands was the real outlier. Their most wanted painting was a small abstract work, and their least wanted painting was a realistic indoor scene. So this is a really interesting artwork to consider when we're talking about bowerbirds, because people think bowerbirds are an example of animals exhibiting culture. So keep these ideas about the evolution of beauty and culture in your mind as we talk more about bowerbirds. And first of all, I want to tell you, there is no way I can tell you everything about bowerbirds in a single talk. I'm going to only tell you about a few of the 20 or to 28 species that are the most relevant. And today, more than anything, I think of myself as a curator of bowerbird artworks. I went through I'm not kidding, tens of thousands of bowerbird images to curate for you what I think are the best collection of bowerbird artworks. So I'm going to start with the satin bowerbird. Satin bowerbirds might be the most well-known bowerbirds, because if people have heard about bowerbirds at all, they probably heard that bowerbirds love blue stuff. Satin bowerbirds are the birds that love blue stuff. So here you can see a satin bowerbird in front of their avenue-style bower, and then you can see a collection of the blue objects that they have collected. They really favor blue. They love blue pen caps. They love bottle tops. They like blue feathers. They like blue clothespins. They like blue ribbons. I've even watched multiple videos of satin bowerbirds stealing blue drinking straws out of people's cups at picnics. That's how much they like blue plastic straws. And they seem, according to Gail, who has studied satin bowerbirds in great detail, she says that they always place their collections of blue things to the north. So bowerbirds improve their bower building and object arranging skills over time. The bowers of older birds are built more neatly and their arrangements are more sophisticated, which the female birds seem to appreciate. Male bowerbirds also learn from each other, sabotage each other's bowers, and steal from each other. So satin bowerbirds mostly use blue, a little bit of yellow. Here you could see a few red objects, which is actually kind of unusual. And I think this is I've been showing you a lot of images from Cornell's Macaulay Library, which is the most incredible resource ever. But as an example of how, simplistic metrics and, human feedback can really go wrong, they have a star rating system for each of their photos. And each photo is rated according to quality, whatever that means. This image here was rated 1 star, which I just can't believe because it's amazing. It's a satin bowerbird bower with a blue scrunchie in front of it. And I think it's just fantastic. But it received only a single star. And most of the images I'm showing today were rated less than 3 stars. And so, even on the Cornell website, this idea of what is a high quality bowerbird image is not understood. Is it just the sharpness of the image? Does it have to have the bird in it? Or is it the content? There's no simple metric to even think about bowerbird images. So just to remind you again, what the purpose of these structures is that the female bowerbird flies into the bower and then she views the collection and she views the singing and the dancing and she decides if she likes this guy. So though these birds really favor blue, they also seem to favor yellow. And I've noticed that a lot of times in these images and videos I've seen of the satin bowerbirds, they're holding a yellow leaf or a yellow flower at the same time as holding a blue object. And this is really interesting to me because it seems to me like this species of bird has some idea of the interaction of color. By the way, this is an example of a younger satin bowerbird. As it's getting older, they turn from green to blue. So you can see that this male is kind of partially in its transformation from green to dark feathers, black feathers. Okay, Vogelkop bowerbirds. So Vogelkop bowerbirds have the most complex bower situations, and they really go for color. I think we should watch this video of David Attenborough again talking about Vogelkop bowerbirds so you can really appreciate how incredible they are.
The Vogelkop bowerbird. He might lack the plumage, but he's got an extraordinary repertoire of song. And he's a wonderful mimic. Those are pigeon wing beats. That's a modest tiger parrot. And that, a sulphur-crested cockatoo. Even more surprising, he's an avid collector with a very appreciative eye for colour. This male favours red and orange flowers. And he's very fond of fungus. Not everything he collects stays where it should. He puts these treasures on display within and around a construction that has taken him years to build. A giant bower woven around a central sapling, carpeted with moss. This grand design is no nest, it's the ultimate seduction parlour. But he's not alone on this hillside. He's got 6 rivals within earshot.
They're Bowerbirds.
This one prefers darker colours, decorating his bower with deer dung. And charcoal. Visual effect is of crucial importance. Clearly, he hadn't planned on all this sprouting fungus.
I love this. It's so particular. So Vogelkop bowerbirds, I mean, they do use blue. There tends to be blue, but they also use pops of other colors. They use orange and red. And they do make piles, but they often will place single objects, the way you see this bird here placing a single red Coca-Cola can. And this is one of the most fascinating things to me about them, is because you can't really describe what they're doing as just getting the most of any sort of object. They're clearly creating visual compositions with the objects. They're placing things, they're like stepping back, they're looking at it, and they're deciding if this is working or not. So I have a lot of pictures of Vogelkop bowers because just the range of what they do is incredible. So I'm just going to go through those really quickly. You can see that they collect different colors. Sometimes it's about an accumulation of objects. Sometimes it's about placing a single object. And as you look at these, you're just going to see that they're so particular about their compositions. If someone comes and moves their objects around, the bowerbirds will come and they will move the objects back to where they were. And if someone comes and adds foreign objects to their bowers, these birds will take them out because they don't belong there. I mean, these really please my human eyes, like the way my eye flows around this composition and looks at the scale and the texture and the color. It really feels really good to my artistic eye. Here you can really see how big these things are. They're a lot bigger than you think when you look at the images. They're pretty large. This is David Attenborough, of course, with a incredible bower. And one of the interesting things about bowerbirds is people have tried offering them the same type of object, an array of different colors, and different types of bowerbirds will definitely favor certain colors over others. And different populations of birds of the same species might even favor different colors and types of objects, which is why some people think that bowerbirds exhibit culture. With bowerbirds, there's just this constant question of why are they doing this? How does making these arrangements show the female birds that they are better mates, that they have better genetic material? Because that's the idea behind evolution. Does doing these arrangements show the females that they have better genes, that they are stronger and healthier in some way? Why isn't it that the bird with the most stuff wins? And we don't know. Some people have asked, does the rarity of the items that the birds collect, does that show that the birds are superior in some way genetically? People looked at this, and it's actually the rarity of the items they collect plays no role. Bowerbirds use what's ever easily around them. With great bowerbirds, they use less color, but this is the only bowerbird where we really have some understanding of a little bit of why they're doing what they're doing. We've discovered that the way they arrange objects creates an optical illusion using forced perspective. So this is a great bowerbird. You can see they build an avenue type bower, and they're collecting gray, green, and white objects around it. This is an example of an artwork where a painter is using forced perspective. They're creating this illusion that all of these squares are at the same depth, but they're actually all at different depths. This is actually quite similar to what these bowerbirds seem to be doing. Not that long ago in 2010, some people studied these great bowerbirds, and they discovered that they create a gradient of gray, white, and green objects of different sizes to create a similar illusion of each item being at the same depth. Someone could come in here and shuffle these items around, those rocks around, and those birds will come and put them back to the way they were. So you could see like what they're doing is they're putting the biggest rocks and items at the further away from the bower, and then the smaller things are closer to the bower. And so when the female bird flies into the bower, everything looks like it's the same size. Now you might ask yourself, does this optical illusion make the male birds appear bigger or stronger to the female birds? In fact, it's actually the opposite. So we can't even use that as a simplistic, explanation for why they're doing these sorts of things. I could just show you a few more of these. You can see they really love white stones. They love green glass, green fruits. They use a little bit of red, but not too much. Shells and bones. Spotted bowerbirds also have beautiful arrangements of green, gray, and white objects. To me, no one ever has studied this in detail, but to me, it also looks like they're creating this sort of a forced perspective illusion. I love this one with just screws, green glass, and shells. They like these green fruits. They love green glass. Especially when I look at images like this, I do sort of get the sense that they might be creating this sort of depth illusion. Again, I want to just emphasize this image has only been rated 1 star. I don't understand how this could only be 1 star. This is incredible. This is a great bowerbird that has built a bower using white stones, pieces of glass, metal clips, silver tinsel, zip ties, and Christmas ornaments. Like, this is such a great bowerbird artwork. 1 star on the Cornell website. Okay, so I've only shown you a few bowerbirds. There are so many other kinds of bowerbirds, and they're very fascinating. To me, as an artist, I really like the satin bowerbirds, the Vogelkop bowerbirds, and the great and spotted bowerbirds. I feel like their sense of composition, texture, color, and scale, like what they're doing really pleases my human artistic eyes. But the other species are extremely interesting too. So I'm just going to like mention a brief couple things about them. But if you really want to learn about them, it's worth it. You should do it on your own. Golden bowerbirds, they're beautiful. They're yellow, but they favor this light green material. They work with, I mean, you can see it's sort of like an avenue bower, and they work with this green lichen and green flowers. Not in this image, but some bowerbirds are actually painters. They will paint the interiors of their bowers with berry pulp and other substances that produce color, often red and purple. Again, just to emphasize how the failure of star ratings, this was rated 1 star, I think. It is one of my favorite bowerbird compositions. Just the placement of each sprig of green flowers and like these little green, whatever this is so delicate and so particular. I find it just exquisite. And I mean, it's a 5-star composition in my opinion. So some of these other species build simpler bowers. They're like messier and they don't have as complicated objects around them. But sometimes these birds have showier plumage. That kind of gives us a sense like maybe different bowerbirds evolved in different ways, because if you have showy plumage, you don't need showy collections of objects. Maybe their bowers don't need to be this showy because they're so showy. But you could see like flame bowerbirds such as these and regent bowerbirds, which are extremely brightly colored. They still build a bower. They still collect objects, but their techniques are not quite as sophisticated. Definitely worth watching the David Attenborough video of flame bowerbirds. It's very, very sultry. Some bowerbirds, they don't build exactly the same type of bower. And you know, all these different species of bowerbirds give us hints as to why they may have evolved this way. These are McGregor bowerbirds. They don't build a bower that the females will fly into, like the maypole bowers or the avenue bowers. They build this kind of, I don't know, arrangement around a sapling. And then there's like this runway around the sapling where there's this kind of complicated mating dance. So there's a bed of moss and they collect objects around it. I really love this image. You could see this collection of wood chips around this structure. And I don't know if that's charcoal, but it's really amazing. Some of the bowerbirds don't build bowers at all, but they still exhibit this tendency to present collections of objects. Tooth-billed bowerbirds collect green leaves and they will make arrangements from them. And one of the things that's, you know, just really amazing is that all these bowerbirds who tend to use things that wilt, like flowers or berries or leaves, they actually have to take the wilted ones out and put fresh ones in. And really maintaining these compositions just requires so much dedication and work. Okay, so one of the reasons I think bowerbirds are fascinating is because what they do is controversial. People don't understand what they do. In 2017, this book came out by Richard Prum about the evolution of beauty that had a whole chapter about bowerbirds. In 2018, Gail, who is here today, wrote a rebuttal to this book, disagreeing with a lot of the theories in this book. So the fact that these birds have evolved to be so varied, and they really seem to defy these simple metrics that we might expect about survival of the fittest, like strongest, fastest, and most. Like that this all breaks down is what fascinates me. And the fact that we're still arguing about what these birds are doing is what I think is so interesting. Other than the forced perspective illusion that I mentioned about the great bowerbirds, what these birds are doing is difficult to put to words. As someone who's a computer scientist, I look at these compositions that these birds are making, and I would struggle to write an algorithm or to write code that is doing what these birds are doing. And this leads me to my next point. People in the tech world usually can't explain what artists do. It's hard for most people to explain what artists were thinking, what makes art good or not. Like the fact that you can't explain what makes a piece of art good or not frustrates a lot of people who are computer scientists. What are your metrics for success? This controversy has emerged with like new fervor with the idea of generative AI making art. And this controversy around generative AI and art is like exactly what people are arguing about with bowerbirds and what they do. Do bowerbirds make art? Is a generative AI making art? What is the metric for success? What makes it art? What makes it good art? You've probably seen these headlines this year. AI companies have scraped people's artworks without their consent and used it to train AIs that make, quote, art. Some of these AI-generated images have won contests, which upsets some people and delights others. This is an example of an image that was, I think it was made in Midjourney, that won an art contest. It upset a lot of people. And as, you know, I don't think it's that good, but as these AI systems learn and improve, will they eventually evolve into being artists that make, quote, great art? The artist himself, he wrote, "This isn't going to stop. Art is dead, dude. It's over. AI won, humans lost." And 20 years later, it feels like we're back at the 41 Shades of Blue again, only I'm not sure my scary stories about local maxima are going to work this time. So I'm an artist. I usually can't tell you why I'm doing what I'm doing. I don't know what something's about until after I've made it. Even then, it can be hard to verbalize. But one of the ways I answer questions is by making something. And the only reason I can tell you so much about Bowerbirds and AI is because having to do this talk made me think about it. I had no choice but to like figure out what is all this about. I'm currently building something called Bowerbot, which is a project to explore all of these ideas with the help of MIT's Center for Bits and Atoms. So I just want to say Gail has built robotic bowerbirds. She's built female birds that do the dancing motions and in order to understand the way birds communicate with each other. But what I am doing is different. My current plan is to work with a robot arm or possibly some other type of suspended system like the suspended 3D printer. And I want to install my robotic male bowerbird in a white gallery space that's completely empty. And I want people to offer it colorful objects that it can either accept or reject. And then it's going to make compositions like how a bowerbird would. And the way I'm going to train this robot to do that is with AI and machine learning. So in addition to the usual challenges you're going to have with building a robot of any kind, picking things up and putting them down and all that, there are some unique challenges to this problem. First of all, bowerbird compositions are meant to be viewed from inside the bower. I've looked through tens of thousands of bowerbird images. The only image I have ever seen of a bowerbird composition viewed from the correct vantage point was from this paper about forced perspective, and this is the only image I've seen. So only one image I have seen from the correct vantage point. In general, there's actually not that many bowerbird images just in general. And that's because they're very shy birds. And some of them are very, it's very difficult to get to where they are in order to study them. So the fact that you don't even have a quantity of images to train in a machine learning or an AI system is one of the problems. Another problem is that we have eyes that face straight ahead. Bowerbirds, have eyes on the side of their head. They probably have a blind spot in the center of their vision, and we really need to think about how are bowerbirds perceiving these compositions? What does it mean to them? And so I think I need to understand a little bit more about how bowerbirds see in order to even be able to explore this problem. Finally, I've looked at a lot of historical illustrations of bowerbirds, and to me, when I look at these, the compositions in the illustrations are not as successful as what bowerbirds do for real. I think this is because the artists don't understand what the bowerbirds are doing, and so they can't present very well what they're doing. They don't understand what the bowerbirds are doing, and that's why the compositions they illustrate are just not as good. So just in the last few days, I've sort of had this realization that what the AI industry is trying to do to human artists, Sophia, who is an artist and a computer scientist, is trying to do to the bowerbird. And I kind of feel guilty about it, actually, but I decided I'm still going to do it. But I do feel kind of bad that I'm, just trying to use AI to make sense of bowerbirds. But in doing this project, I'm hoping it's going to help me make sense of a lot of the things that confuse me about generative AI and what art, beauty, and optimization are. So here are just some of the questions I hope will become more clear as I do this. So are bowerbirds artists? Can a generative AI be an artist? If a human artist creates an AI artist, who's the artist? I mean, how do all these ideas fit into our notions of creativity and beauty? And the tech world is really preoccupied with ideas of optimization and efficiency. What is optimal if there are no clear objectives like strongest, biggest, or most? This challenges the mainstream understanding of evolution and survival of the fittest. There are no clear objectives with art. A bower composition will fail if a male bowerbird does not attract a mate. Is the only metric for success with generative AI is if humans are successfully fooled. Should we be treating art, design, and beauty as an optimization problem at all? What is culture? Do bowerbirds exhibit culture? And can generative AI have culture? And I've sort of realized this yesterday. Even if I build something that works, does doing all this even help me learn something about what these birds are thinking and doing? Machine learning is a black box. We don't know why it does what it does. We only know if it produces good results. Does a generative AI succeeding at making great art actually shed any light on what artists do? This sense of not knowing reminds me of this artwork by Sophie Call called Take Care of Yourself. In 2007, a boyfriend broke up with her over email. I mean, this makes no sense, being broken up with over email. If this happens to you, you would talk to all your friends about it, about what nonsense it is. What the heck was this guy thinking? So what Sophie Call did is she asked 107 women in different fields like anthropology, criminology, philosophy, psychiatry, theater, opera, soap opera. Like, she had handwriting analysts analyze this letter. And all the results of analyzing this letter are what she exhibited. I mean, I love this piece so much, but all this analysis doesn't make this email breakup make any more sense. Maybe the Bowerbot will be a celebration of not being able to fully understand, of not fully knowing why bowerbirds are doing what they're doing. Will we ever be able to understand why bowerbirds do what they do? And will we ever be able to explain what great artists do? So, I mean, this project is a work in progress. I welcome all ideas and comments and questions. Please reach out to me if you have thoughts. But now I want to invite Gail to the conversation, who studies birds, and I would like to hear what reactions she might have, and then we're going to open it up to everybody else. I think I'm going to stop sharing my screen.
Hey, that was great, Sophia.
Thanks, Gail.
So you want my reactions? Excuse my
react.
voice.
Yeah, I want to hear what you think.
I keep thinking when I'm listening to you talk about bowerbirds that yeah, as an evolutionary biologist, we've been, I think, grappling more and more with the complexity of animal behavior and animal signals, and especially in the species like the bowerbirds, where they have these just gorgeous, elaborate breeding displays. And they're never simple. The stronger the sexual selection, like in species like bowerbirds, the more complicated they get, and they involve dance and visual and sound and sometimes scent. And for many years, by necessity, we would measure each trait separately. So look to see whether there's a correlation between the number of blue objects in mating success, and the symmetry of the bower in mating success, and the intensity of the dance in mating success, and the quality of the vocal mimicry in mating success. And we might look for simple interactions, but we learned a lot this way, but we weren't really grappling with the fact that these all really interact with each other. And it's really more like a performance art piece. And one of the things I found in my research, just looking at one piece of that interaction, is that if males have more blue decorations in their bower, that seems to sort of calm the female down and allows the male to do a more intense dance without startling her. And so there you have this complicated interaction between the visual and then how he can dance. So it's going to affect his dance, the decorations he has. So they're going to just be interacting in complex ways. And
no, but then I can't help but wonder about this holding of the yellow and the blue objects at the same time. Like, why do these birds want to hold one of each?
I don't know.
I think that's, I love
Yeah.
that we don't know.
Yes, absolutely. We often saw them dancing with just a yellow leaf, or blue, and you found these great pictures of sometimes both of them at the same time. I don't know that I ever saw them do that. We didn't have any artificial bower decorations. There were no bottle caps and things like that at our field site because we removed all of them, which is an interesting question in itself, whether that was the right thing to do. But we didn't see that as often, and but I love that they do that, and those are by far their favorite colors, and they give, I mean, they're gorgeous along with the plumage and the eye color of the bird. But a lot of the most
So,
exciting research right now in evolutionary biology is just trying to tackle that complexity and figure out new statistical ways of looking at, and how can we actually study something where you have so many complicated interacting parts. And to me, that's some of the most exciting stuff that's happening right now.
so I've read a lot of, I've been reading a lot of things, including your writing, about how does this process that they have of making this arrangement of colored objects relate to sexual fitness? Like, how is this potentially an indicator of sexual fitness? And it seems like there's not agreement about this. So what do you think?
I have, in my mind, when I think about a lot of species that have these complex sexual signals like this, I have what I think of as a cheesecake analogy for the whole thing, which is that we have this sort of underlying preference for sweet and fatty foods, which was at some point in evolutionary history a benefit, arguable now. But there's that sort of underlying preference that's adaptive, and that is important for us to get nutrition and stay alive and stay healthy. But there's lots of ways to tap into that, right? There's food that has interesting mouthfeel and texture and smell and all these different things that can make food delicious. And all of those kinds of things are what I think of, when you look across all these different breeding birds, it's always that the males have to do something really hard. So they have to dance really hard, but it takes a lot of coordination. It takes cognition. It taps into all these different systems that are hard to do, but the bells and whistles and the differences between species, a lot of that might just be things that just for whatever reason make the female go, ooh, that's cool. and might not all say something in particular about his genetic quality or something like that. But you still have that sort of underlying preference for males who can do something really hard and complicated that draws from a lot of different systems. And that those males probably are healthier, and whether or not those genes get passed down to the offspring, we still don't know. We don't know that in bowerbirds. So there's still a lot of speculation, but that's kind of how I've been viewing these more and more. So it's tapping into the aesthetics of the female, but probably also saying at least something about the quality of the male.
Yeah, I wonder if like making the most wonderful bowerbird composition somehow shows that the male bird is smarter. It's a smarter, better intellectual bird.
Yeah, so there have been a few studies that have tried to figure out ways of looking at that, coming up with little puzzles that the birds have to solve, like, some sort of little puzzle box to see if they can get the blue decoration out of the box, or to see whether satin bowerbirds don't like red on their bowers, not in the main platform area, off to the side somewhere. So if you put something red on their bower, they will try to get it out of the bower platform. And so there was another sort of puzzle on, can they get rid of this other thing? And there was a relationship between males that were better at sort of solving that puzzle and mating success. But whether or not that's measuring some small aspect of their cognition.
Mhm.
I don't know if it's capturing smart in a broad sense, which is a very hard thing to do.
Yeah, I don't well, the fact that we don't know is one of the most interesting things. And I have the suspicion that we probably have a lot of questions about bowerbirds that maybe Gail and I can answer. So maybe we should open up to the audience if they have any questions about bowerbirds.
I did see that there are many questions in the chat, but as we mentioned before, you can use the hand up as Mark has done and join the conversation. So Mark, would you like to ask your question?
Two things that I find interesting, especially after this fascinating talk. And one of them is the robot arm that that Sophia was talking about to try and simulate Bowerbird art. And I'm wondering if anybody has had similar ideas, producing the circles in the sand that the white-spotted pufferfish make, which is it's got a lot of publicity recently as the other species that seems to be artistic in addition to the bowerbird. I reckon there are probably thousands more that we don't sense. But that's one question, whether similar work is being done on the pufferfish. And my other question is a little bit more philosophical. When we think about human art, we think about all the great names, all the tendencies and so on. And when we talk about non-human animal art, the first words that seem to come in, that seem to spring up are reproductive success, attracting a mate. Well, undoubtedly that's a triggering factor and a driver for producing art. But perhaps to increase our understanding of it, those of us humans who produce art should ask themselves, really, to what extent the art that they make is motivated by trying to find a mate. I mean, probably more so when we're adolescents, but then the art seems to acquire a momentum of its own that's independent of this quest for a mate. And there's a rather fanciful version that has arisen, which is that you could argue that not only do we use art as a way of reproducing, but art actually uses us as a way of propagating itself, which is a bit philosophical and fanciful, but I thought I'd put it on the table anyway. Thanks anyway for listening.
Well, that's pretty interesting. I do know about the pufferfish. I don't know anybody who has tried to study them. I think the idea of presenting a human-made artwork to some other animals and having them assess whether they like it or not is quite interesting. I have to say, as an artist, when I make art, I'm not thinking about attracting a mate. There's definitely other reasons for my artistic practice besides attracting a mate. But the question that's really interesting to me is like, how do we, I mean, with animals, we know like the work is successful because they've attracted a mate. If you're looking at a generative AI system, what is the metric of success? Is it that it fooled a human? Is that our metric of success for whether it's good or not? I mean, the generative AI is not going to attract, well, maybe in the future it'll attract a mate, but how do we, how do we put these things in context? Anyway, Gail, if you have thoughts, feel free to add. But yeah, my art making is not for the attraction of a mate. Maybe I would collect more blue objects and present them if that were true.
Con, would you like to ask your question?
I haven't seen a lot of bowerbird photos, and I've never seen bowerbirds in the wild. But just looking at some of your photos and remembering some of the ones that I've seen, it seems to me that there's an element of a golden ratio involved in the structure of the thing, either as Fibonacci ratios or as 1 to 1.6 ratio between some of the structural elements, like some of the grass versus some of the stones put in front could be described as a 1.6 to 1 ratio. Is that totally off the wall and erroneous, or is there some element of truth in that?
Gail, why don't you take this one?
Yeah, that's a great question, Con. I don't actually know if people have looked at that aspect of it. the satin bowerbirds that I studied, at least for blue decorations, it really just seemed to be more is better. They put sort of a layer of yellow and white down, and then the more blue they could find, the better. The Vogelkop bowerbirds, the ones that have those gorgeous piles of different colors, that's where I think you might find it'd be very interesting to look at the balance between them. And they're very different. You'll find one bower that has a giant pile of orange and a few small piles of other things, and others that have lots of different sized piles. So I'm not sure whether you would find that, that relationship that holds across all of them, but it would be fascinating to look at, and I don't know that anyone has.
Well, thank you. As I'm sure you all know, the Fibonacci ratio and the golden ratio are important elements in human art. And some of the physicists like Neil and Vint could probably tell about how important they are in the structure of the universe. So I'm just wondering if there is a universality to all of this that connects bowerbirds to the rest of human artists and the universe. Thank you.
Well, I wonder about that because I have to think about the way our eyes work and the way the bowerbirds' eyes work. I really want to understand what their perception of color is and what their perception of depth is. Maybe if we take a bunch of pictures of what these bowerbird arrangements are from the correct vantage point, we'll start to see those golden ratios, but there's just not enough images to know yet.
Yeah, that's a good point. You would have to measure it from the perspective of the female to really get at that.
But also as an artist, I could tell you that I don't, I don't just set out and say like, I'm making this painting, I'm going to use the golden ratio. I don't sit there with a ruler and do it.
I think that's a fascinating provocation. Maybe this is something to provoke or to invoke in some of our researchers in the group, because I think that's a fascinating thought. Thank you for the question. Let's go to Neil. So Neil actually helped us to invite Sophia here today. So I think this is great to have a question coming from you, Neil. Thank you very much for the connection to bring Sophia and Gail.
It's a pleasure. The talk was great, and I look forward to working on the robot. The question is, do male bowerbirds have a day job? What do they do when they're not building the bower? How much time do they spend? Does the time change after they succeed at mating? Is this like they're just in the man cave, or what else do they do? And then again, when they succeed, does it change?
Gail, I'm going to let Gail take this.
Yeah. So bowerbirds are a breeding system where their success is, they will mate with the female and then turn around and court the next female. So they are 90% of birds, they would pair up and raise the young together and build a nest together.
Some of the bowerbirds are that way, right? Some bowerbirds are monogamous.
Catbirds. Yeah, there's a few monogamous species in the group, but bowerbirds are one of the less than 1% of birds where the males just are absolutely showy and spectacular and try to mate as often as they can. So I would say that a male bowerbird would never consider his job done until the breeding season is over. And throughout the breeding season, everything is about mating. So they spend most of the day at their bower perfecting things, searching for decorations, eating, they have to eat, stealing decorations from their neighbors, knocking down their neighbors' bowers, and then coming back and building theirs back up again. So they're really sort of monomaniacal about, about their breeding display.
There's no obligation after mating. They go back to the man cave.
No obligation whatsoever, no. And often there's often a peak of breeding the birds that I study now, the sage grouse, have a similar breeding system. And the top male may mate, our record holder mated 27 times in one morning, 23 times in 23 minutes. So the extent of their relationship is a minute.
Gail, someone asked an interesting question in the chat. Do the bowerbirds, how often do they start over when they're making a bower? Like, do they just start all over, or are they always working in the same bower?
We found the same bower sites year after year. They would be in the same pile of broken down sticks from the previous year. And those are, they often tend to be a good location right next to a log, and there's a beam of light that might come through the forest right down there. But we also have seen them change locations, but they really do. There are certain locations that they like, and they'll rebuild back there. So we have occasionally seen them move around, but for the most part, they stay with the same bower, and they only really rebuild it when their neighbor knocks it down. But the vogelkop bowerbirds, the ones with the huge huts that are so spectacular, those are up year round. There's no real breeding season. So they keep that going year round and maintain it year round. And they don't really destroy each other's bowers because they're a meter across, and these are little birds. So I think it'd be too hard to destroy.
It looks like we have a couple other questions.
Joanne, would you like to go ahead?
Yes, good morning, and thank you so much for the talk today, and welcome everybody back. I have kind of a complicated and convoluted question, so hopefully I'll be able to articulate it well. But I wanted to know more about the pigment selection, so the colors that the bowerbirds are selecting. And I'm sorry, I have my daughter with me, so she might babble a little bit behind. So I'm thinking specifically of the blue, right? We know that blue is a very expensive color to be made in nature, right? And even in human artistic history, blue was always an expensive pigment, right? I think about ancient Egypt and lapis lazuli making blue as a color pigment. And I'm trying to put together this idea of how AI is going also to be making selections of color and how AI might reproduce human art. I like that idea of thinking about success of like, did it fool the human, right? But will it consider the historical aspects of pigmentation used by humans or color used by humans? And will it take into consideration the natural history of bowerbirds, for example, whenever it's thinking about recreating or with the particular robotic arm, right? That you're thinking about, Sophia, like will natural history be put into consideration into the equation? Because as I'm thinking about these metrics of success that you're talking about, I worry, similar to what you're talking about, if we are going to end up in a situation where we are using historical data, and as we saw in the photos, there was a lot of man-made materials, so plastics, right? There were probably in the natural history images that you showed, there were no man-made materials, just natural materials. So anyways, as I said, this is very convoluted, maybe not really a question, but I would love to hear more about it.
Well, I can start, or go ahead, Sophia.
Well, I just have a brief comment. Like, my first reaction is that a lot of this seems to be like the relationship between art and culture. I mean, there's like the artistic impulse, but then you're reacting to what's around you. And these birds are also kind of reacting to what's around them and the population of birds that's around them. So they're reacting to objects around them, and they're reacting to what the other birds are doing. And so that is what comes to mind when I first think about this. But let Gail respond.
Yeah, I'll say that it's in birds and in most other organisms that have blue coloration. It's not a pigment. It's a
reflection and
structure.
refraction. Yeah.
Yeah, it's yeah, exactly. It's a structural color. So it's about just refracting the light in particular ways. But it is fairly rare. And so in the bowerbirds, the blue crimson rosella feathers were the sort of prized object, and they would steal them from each other's bowers, and they would move back and forth. But somebody did a study where they sort of flooded the market with blue, and they went out and just put a bunch of man-made decorations out in this population. And they found that once the market was flooded, they were no longer stealing each other's decorations very much, and females didn't pay as much attention to the amount of blue when they were making a mate choice decision. So it's sort of like they devalued the currency by flooding the market. And so that was just a really interesting example. And so I guess when people come in and
That is super
blue
interesting.
bottle caps, you could have the same thing occur.
That is
I mean,
so
that's just like the
interesting.
art world.
I only know one. Oh, sorry, Sophia. I only know one animal that produces the pigment blue, which is mandarin fish. I haven't heard of many others that do. So yeah, thank you for that answer.
It looks like we have one more question.
Go ahead, Francine.
Thank you. Thanks so much for a wonderful presentation. It's so fascinating. And I just wanted to say to Sophia, I'm also at the University of Michigan, so go blue, and blue is obviously very relevant here.
Well, hopefully I run into you soon.
So thank you both, Sophia and Gail, for really fascinating discussion, and to the entire audience for the questions, because I think that we're getting at such interesting questions here. So I had a question earlier on in the presentation. Sophia had mentioned about individual differences and that this might be an example of culture. And I just wanted to ask if you could comment on that, like how you see the individual differences as being part of the culture within these bird populations. And then I had another comment, if that's okay, but I'll leave that first question. Thanks so much.
Oh, sure. Anyway, I noticed when I was doing my research that different bird populations of the same species, if they were geographically isolated, they over time evolved different preferences for types of objects, arranging styles, and color. But maybe Gail has some more insight into different studies that have been done.
Yeah, so we definitely saw individual variation. Even within our population. One guy was successful with a really thin but symmetrical bower, and another guy had a very thick symmetrical bower, and both of them were successful, which I also found interesting because that suggests that females might have differences in what they're interested in as well. But there's definitely individual variation. But when you look among populations, there are some differences, and vocal mimicry is one of the cases where you see that. So they'll mimic different species from the surrounding area as part of their courtship song and dance. And in different regions, they'll mimic a different group of species, but all the males in the population will do this same sort of collection of species that they're mimicking, and that varies across the range. Along with the birds that are around them that they are hearing. So that's one example of culture. A lot of the other kinds of examples of culture are things like, differences in the bird song, that they're learning the songs from each other. And so they'll sort of morph like dialects in different populations.
That's fascinating. Thank you. I had another question or sort of thought. So I work with virtual reality with non-human primates, with apes and monkeys, navigating and in space and in choosing partners to cooperate with or compete with. And I was wondering, I don't know that anybody has looked too much at aesthetics well, I had 2 points of this with particularly with the non-human primates, but we have created a rainforest for bonobos to navigate in. So these are captive bonobos, and we gave them this environment and we just let them go just to see what they would do, as if we were watching them in the wild. But of course, they are captive and they get this chance to do this in captivity. And we gave them up to 3 sessions, so 12 minutes per session, per trial. And they will spend 36 minutes traveling around and navigating and looking at things in these environments. And they're huge environments. They can take 45 minutes to travel around them, because I've tried it. And some of it to me seems like they're just interested in looking at things because they're used to being in captivity. And even if that's enriched, it's not the same. And the environment is really, the virtual environment is really quite beautiful. So I was thinking about their ability to perceive the beauty of these, even though it's a virtual environment. And I don't know, we haven't tested that at all. We were looking at navigation and so on and exploration, but I think that relates to the aesthetics. And then I was thinking about whether or not you could do something like that, presenting a virtual environment or virtual objects to a bowerbird, if you had some in captivity that you could test and see what objects they choose. And put in their nest and so on. So those are just two comments. I don't know if that's relevant or interesting, but hopefully.
Oh, it's
Oh,
really
very-
interesting.
Yeah.
I
Very
would definitely want to try out art on bowerbirds. I mean, again, it goes back to the point, I need to understand how their eyes work a little bit. I mean, with the way humans perceive depth and color, like I know a lot about the way like the cones in our eyes work, why complementary colors tend to vibrate, why, how our perception of color is very particular to the way the biology of our eyes. And so I think I would have to think about like the way I'm not even sure how much we know about the way bowerbirds perceive depth and color, and how that might affect their perception of a composition. Because I know with like we use all those tricks as human artists with like yellow on white causes vibration, complementary colors cause vibration, the pairing certain colors cause some things to come forward versus back. So artists use all those tricks often intuitively to create a composition that the human eye wants to go around. And I think that's what bowerbirds are probably doing, but they have different eyes than we do.
One of my graduate students, Jessica Yerzinski, did a study where she put an eye tracker on a peahen. And they were fabulous. They were this big. They made their look like a cyborg peahen. But she would go out and look at males while they were doing their big display of their train. And so she was trying to study what females are actually looking at when there's a male in front of them with his gorgeous train out. And it was very surprising. Most of the time they weren't even looking at the male, but when they did look at the male, they would sort of look at his body and then out to the side of his train and then back to the mane and then out to the side. And so they were sort of making these, the saccades along the bottom rather than sort of looking at the whole display like I think humans might. And there's still a lot we don't know about their perception, and often, we can't say that they weren't seeing the rest of it. We just know where their attention was. But it was, it suggested to me the fact that they looked at it in a way that I think is very different to how humans would look at that, just suggests that there are just differences in how we might perceive things, which things might capture our attention. So that's one, chipping away at one little piece of that. And there's some cool research to show that birds see black and white contrast different than humans do, and how they see color contrast. I think I'm not sure how much at all we know about that. So there's a lot more to figure out.
We did a little pilot study with Kias and with virtual reality. And so I couldn't say how they're viewing it, but they certainly played around with objects and moved around and navigated. So that was kind of cool. Thank you so much. It's really exciting.
Oh, thanks for the question. It looks like Bia has a question.
Hi, hello. First of all, thank you for this talk and conversation. It's been very stimulating. Mine is a sort of a basic question. I was trying to look at what's in it for bowerbirds if we think of them as artists. So I was wondering if perhaps you could talk a bit more about how thinking of them as artists or their populations as cultural clusters could help us look at animals as individuals, contest the idea that they're automata or anonymous members of species.
Well, one of the things that's kind of funny to me is like we don't because we don't completely understand what they do. It's been labeled art. It's like art are the things that we can't understand or easily quantify using metrics. And so because what bowerbirds do is so hard to understand and hard to quantify using metrics, it must be art. But maybe Gail has some thoughts on this too.
I found it interesting when I talk to people outside of biology or outside of a group like this that's very interested in understanding how animals think and the sort of interface between how we think and how animals think, that people do very much view them like you were just describing, like they're little machines with input, output, without a lot of individuality and personality. But most of us who study animal behavior We just, I mean, that's what we study. We love the individuality and the personality and the, you know, we don't tend to view them that way, or at least most of us don't. And yeah, I think being able to show people the variation in how males choose to use decorations in their displays is a great way to show people that these are not just machines, that they really are, you know, expressing their aesthetic sense. And so, yeah, talking about bowerbirds, I found, is a very powerful way to sort of get people out of that mindset of viewing animals as little robots.
Thank you.
I love that.
We also had our final lecture last year, actually, with Carl Safino, talked a little bit about this, about the culture of birds and the individuality and the connections that occur. So I think that might be also an interesting place for you if you're interested in that topic. Yeah, it's quite an interesting one. It's on our YouTube.
Okay.
Yeah.
I'll look for it. Thank you.
Yeah. You're welcome. Thank you. Are there any final comments or questions for our speakers today, Sophia and Gail? I'm going to pop, as we usually do, I'll put in the chat our Slack community link. So if you have any other thoughts or you'd want to connect with anybody else in the meeting, you can also jump onto the Slack and see if you can pose your question there. You're always welcome to. And we also add some of the details that have been shared in the chat. And if you do want that chat, you're welcome to contact us and we can pass it over, because there's often great references and bits and pieces. We do have one final question from Bill, who's just put it in the chat. Maybe, Sophia, do you want to take this one, and then I think we can
I think this one is for Gail. Are there
Okay,
predators that influence the routine of bowerbirds?
So bowerbirds in Australia and in New Guinea, there aren't a lot of native ground predators. And I mean, there are a few, but there aren't as many as we have around here. And so that's one of the ideas of how they've been able to build these ostentatious displays on the ground, is that they don't have a lot of ground predators. So introduced predators like cats are a big problem. But we've almost never seen predation. They get in the nests get eaten by predators, but the adult birds rarely do.
I think that makes sense. My art is the best when I'm free of predators, so I think that makes total sense.
I think there's a lot of really supportive words in the chat today, and I think that, you know, we're all really resonating with this talk, that it really also shows what we're doing as part of this community, which is bringing these different voices together, bringing these different ways of looking at you know, non-human animal species. We're bringing these into a light, and I feel that, you know, this is a great way to have kicked off our 2024 Talks program, which we're really excited to present to you all. Thank you so much, Sophia and Gail. This has been just a wonderful presentation. And
this was so much fun.
Yeah, and as someone who grew up with bowerbirds in my backyard, I now am going to see them so differently. So this is just really exciting. Thank you so much for bringing this amazing, well, we could say we think art to life. Yeah, watch this space. I guess we need a little bit more clarification here. And yeah, thank you everybody for joining us. This is wonderful discussion and all the questions. As I said, if you need any content from the chat today, you can contact us and we will put this onto our YouTube as usual. So thank you very much for joining us. Thanks again to Neil for inviting Sophia to join us, and wishing you all a very happy weekend.